PHOTON2 Lenses Labs gives you an opportunity to see what happens when the image formed by one lens becomes the object of a second lens. The calculations are somewhat more complicated than in the single lens lab. Nonetheless, it's simply repeated applications of the thin lens equation. It's just a matter of keeping the steps straight. To set up the lab, we begin with something that looks exactly like the single lens lab. We have the ray box serving as our light source, an object. It's on a post and post holder and resting on a tilt table. And in front of it, we have a 10 centimeter focal length lens. This is fastened to the breadboard because it's not going to move. Its only purpose is to provide for us an image which will serve as the object of the second lens. So once that image distance is found, we put something on the optical table so that we know where that image location is. Now the light that forms that image becomes the object for the second lens. This lab takes a rather long baseline because some of the images are going to be formed at quite some distance from the second lens. So you would certainly want to do this on a table longer than the one that I'm using. We're going to take the second lens, which has a 20 centimeter focal length, and we're going to form 3 different systems and see what happens to this object that was an image as it's imaged by the second lens. The first system has the object located here outside the focal length of lens number 2. So this is a 20 centimeter focal length lens. Its focal point is right around here somewhere, and this object is beyond it. As you know, when the object is outside the focal length, a real projectable image forms on the other side. The second system that we'll create, we move this lens back so that its focal point is now on the other side of the object. Remember, this is where the image formed by the first lens, and that is the object of the second lens. And the second lens focal point is about here. Now you know from working with single lenses that when the object is inside the focal point, then we have a virtual image, and we need to actually look back through the lenses to see that virtual image. The third system puts the lens itself on the other side of the object. To do that, I'm going to have to readjust the height. The height had been set so that the object and the 2 lenses were all along a horizontal line, the same distance above this table, even when this lens was moved off of the optical table. So for this system, lens 2 is on the wrong side of the object. Usually the object is over here to the left. Now the object is to the right. This is a virtual object, and we can handle it by realizing that if it's on the right side of the lens, by our Cartesian sign convention, it's an object with a positive object distance.